Chapter 4. Laws of Motion. Summary 1. Aristotle's view that a force is necessary to keep a body in uniform motion is wrong. A force is necessary in practice to counter the opposing force of friction. 2. Galileo's extrapolated simple observation on motion of bodies on inclined planes and arrived at the law of inertia. Newton's first law of motion is the same law rephrased thus: everybody continues to be in a state of rest or of uniform motion in a straight line, unless compelled by some external force to act otherwise. In simple terms, the first law is: if external force on a body is zero, its acceleration is zero. 3. Momentum p of a body is the product of its mass m and velocity v. P equals mv. 4. Newton's second law of motion. The rate of change of momentum of a body is proportional to the applied force and takes place in the direction in which the force acts. Thus, F equals k dp by dt equals kma, where F is the net external force on a body and a its acceleration. We set the constant of proportionality k equals 1 in SI units. Then F equals dp upon dt equals ma. The SI unit of force is Newton. 1 Newton is equals to 1 kilogram meter per second square. A second law is consistent with the first law. F equals A implies A equals 0. B. It is a vector equation. C. It is applicable to a particle and also to a body or a system of particles, provided F is the total external force on the system and A is the acceleration of the system as a whole. D. F at a point at a certain instance determines A at the same point at that instant. That the second law is the local law. A at an instant does not depend on the history of motion. 4. Impulse is the product of force and time, which equals to change in momentum. The notion of impulse is useful when a large force acts for a short period of time to produce a measurable change in momentum. Since the time of action of the force is very short, one can only assume that there is no appreciable change in the position of a particle during the action of the impulsive force. 6. Newton's third law of motion. To every action, there is always an equal and opposite reaction. In simple terms, the law can be stated thus: forces in nature always occur between pairs of bodies. Force on a body A by body B is equal and opposite to the force on the body B by A. Action and reaction forces are simultaneous forces. There is no cause-effect relationship between action and reaction. Any of the two mutual forces can be called action and the other reaction. Action and reaction act on different bodies and so they cannot be cancelled out. The internal action and reaction forces between different parts of a body do, however, sum to 0. 7. Law of conservation of momentum. The total momentum of an isolated system of particles is conserved. The law follows from the second and third law of motion. 8. Friction. Frictional forces opposes impending or actual relative motion between two surfaces in contact. It is the component of the contact force along the common tangent to the surface in contact. Static friction Fs opposes impending relative motion. Kinetic friction Fk opposes actual relative motion. They are independent of the area of contact and satisfy the following approximate values. Fs is smaller than equal to Fs max equals to nu SR. Fk is equals to nu Kr. nu s, coefficient of static friction, and nu k, coefficient of kinetic friction, are constants characteristics of a pair of surfaces in contact. It is found experimentally that nu k is less than nu s. Points to ponder. 1. Force is not always in the direction of motion. Depending on the situation, F may be along V, opposite to V, normal to V, or may make some angle with V. In every case, it is parallel to acceleration. 2. If V equals 0 at an instant, that is, if a body is momentarily at rest, it does not mean that force or acceleration are necessarily 0 at that instant. For example, when a ball thrown upward reaches its maximum height, V equals 0, but the force continues to be its weight mg and the acceleration is not 0 but g. 3. Force on a body at a given time is determined by the situation at the location of the body at that time. Force is not carried by the body from its earlier history of motion. The moment after a stone is released out of an accelerated train, there is no horizontal force or acceleration on the stone. If the effects of the surrounding air are neglected, the stone then has only vertical force of gravity. 4. The second law of motion, F equals ma. F stands for the net force due to all material agencies external to the body. A is the effect of the force. ma should not be regarded as yet another force besides F. 5. The centripetal force should not be regarded as yet another kind of force. It is simply a name given to the force that provides inward radial acceleration to a body in circular motion. We should always look for some material force like tension, gravitational force, electrical force, friction, etc. as the centripetal force in any circular motion. 6. Static friction is a self-adjusting force up to its limit nu s, and F is smaller than equal to nu sn. Do not put Fs equals nu sn without being sure that the maximum value of static friction is coming into play. 7. The familiar equation mg equals r for a body on a table is true only if the body is in equilibrium. The two forces mg and r can be different. Example, a body in an accelerated lift. The equality of mg and r has no connection with the third law. 8. The terms action and reaction in the third law of motion simply stand for simultaneous mutual forces between a pair of bodies. Unlike their meaning in ordinary language, action does not precede or cause reaction. Action and reaction act on different bodies. 9. The different terms like friction, normal reaction, tension, air resistance, viscous drag, thrust, buoyancy, weight, centripetal force all stand for force in different contexts. For clarity, every force and its equivalent terms encountered in mechanics should be reduced to the phrase force on A by B. 10. For applying the second law of motion, there is no conceptual distinction between inanimate and animate objects. An animate object, such as a human, also requires an external force to accelerate. For example, without the external force of friction, we cannot walk on the ground. 11. The objective concept of force in physics should not be confused with the subjective concept of feeling of force. On a merry-go-round, all parts of our body are subjected to an inward force, but we have a feeling of being pushed outwards, the direction of impending motion.